Hello friends, so today we are going to study about the intervals coding pattern. This coding pattern has been asked in probably thousands of interviews because intervals coding problem is actually a real life scenario that we use daily in lot of applications. Typically, first let me explain what intervals coding pattern is and where you can identify it. Typically, this coding pattern is associated between these data structures. So data structures, fixed data structures like array, linked list, string, and also heap that uses typically interval type of problems. How do you identify an interval problem is that in most of the cases you are given some time sequence, and in that time sequence you are being asked specific different intervals that are separate from each other or somehow they overlap between each other, and you might be given task to find like a common window or a common space between any two set of variables where you can find some value that is empty in between, and you want to schedule a meeting. So in this example, suppose these are the two different calendars for two different people in working in any company, and you want to find like empty spaces to book a meeting. Then you can find these slots that are available on both the cases where you can book the meeting. This is a very good interval type of question. Second problem we can find is that suppose rather than this you are given only just like a single time sequence, and you are given some scenario where you are given some different intervals, and you are told that this is a new interval that you want to merge over here in such a way that there is no overlap between any existing intervals. So these are just like few of the problems. If we see some practical applications for the interval type of problems, there are practical use cases as I mentioned, such as like calendar management, or sometimes if you want to do like project management where everything needs to be done in a sequential manner and where there is a dependency between one item after the other. So one has to be done in order to complete the second one. So even in project management or calendar management, or like to find a room or find a meeting slot, something like that, these kind of questions typically use intervals, and today we are going to go through every single one of them. So first let's see that what are the typical possibilities we have in any given interval kind of a problem. In this example I'm using this blue one as interval A and this B or the yellow one as interval B, and we are going to see that based on this pink time sequence what are different possibilities between A interval and B interval and how can we handle them. So first possibility is pretty simple, that A interval and B interval are located at different time spaces, so there is no correlation between them and they do not overlap between each other, so that is perfectly fine. Second possibility is that before A interval ends, B interval begins, which means we can find that there is an overlap between this portion. So we might be asked to do something over here. We could have been asked some question that if we see any overlap, we need to get rid of the overlap, or we need to like merge these two. So suppose if we are being asked that we need to merge any overlaps, in this case we would create an entirely new interval that looks like this, where we are going to take the starting point of this A value and we are going to use the ending point of this B value in this time sequence, and then both of these times or both of these intervals would be merged into a single interval. So this is a very good type of interval problem. If we take a look at this example, in this case interval A completely overshadows interval B. So basically we can say that B is completely in between the bounds of value A. So even there will be scenarios where you will have to deal with situations like this. Now this one is the reversal of this situation where we are starting with B and ending with A for this entire merge interval. Same way, this is the reversal of this previous example where now B is completely overshadowing the value A. So in this case, if we have to merge these intervals, there will be a single interval like this. And in this case, since B and A are located at different places, there is no overlap between them, so we don't need to basically do anything. And if we are being asked to find like an empty spot, we can easily find an empty spot between these two portions for these two intervals. So these are just like few of the possibilities that you will have to deal with. And when I say few, I mean all the possibilities that you will have to deal with, because there are only 6 things you can do with any two intervals. In order to better understand the interval problems, let's see some examples. In this case, I'm going to show you 3 different examples. First example is really popular. Second example is like moderately popular and also covers very important key topic. And the third example is actually a Leetcode premium problem. So no, I know not many people have access to Leetcode premium. So that is why I decided to show these three examples. So let's just start with example number 1. Now this first example is the merge interval example. This is Leetcode question number 56. And in my opinion, this has to be one of the most popular Leetcode problems, because even right now, if you see that not many companies are hiring and there are hiring freezes going on all over the world, still this question has been asked by staggering number of companies multiple times. There are companies like Bloomberg, Amazon, Uber, Facebook, Google, Microsoft, Apple, Nvidia, Morgan Stanley, ByteDance, Snapchat, Twitter, Goldman Sachs, and Tesla, to name a few, who have already asked this question recently. So that is why you can imagine that how popular this problem is. So let's take a look at this problem. This one is the Leetcode medium problem, and as mentioned, this is like one of the most liked problems on Leetcode, and the problem statement is really simple. Basically, we are given an integer array of intervals where we are given the values in the form of tuples. So we are given different tuples of interval array, and we are given in a sequence such that every single tuple represents an interval that has a starting value and an ending value. Now we need to merge all the overlapping intervals, nothing more than that. Pretty simple. And when we are done with our merging all the intervals, basically we need to return an array that does not contain any overlapping situation, or all the non-overlapping intervals are present. Let's try to understand this with a couple of examples. If we take a look at this first example, so now I have plotted all of these 4 intervals in a time sequence, and our aim is to find all the overlapping intervals and merge them. So clearly we can see that there is an overlap between these two intervals. Question is, how do we identify that there was an overlap between these two intervals? Well, the answer is quite simple. Before this first interval ends, the second interval begins. Let me repeat. Before we find the ending value of the first interval, if we find an interval that has a starting value before the ending value of the previous interval, which means we can define that there has to exist an overlap between these two. So this is the most basic definition to identify an interval. In this case, we identify that there exists an interval over here. So we will have to do a merge operation. In order to do a merge operation, the answer is quite simple. We are going to take the least amount between the starting values, which is in this case the value number 1. And we are going to take the maximum amount between the ending values, and in this case the answer is 6. So we are going to create a new sequence that is going to look like this, and in the answer we are going to create a merge interval between these two intervals, and these two are not already non-overlapping intervals, so we are not going to touch them, and this is the answer we need to return. Now let's take a look at the second example. In the second example, we are simply given a smaller 1 to 4 and then 4 to 5. So in this case, we are given a line like this. First interval is 1 to 4 and second interval is 4 to 5. Now even in this case, 4 is the middle point for both of them. So the answer is going to be that we are simply going to create an interval that is starting value from 1 and ending value is at 5. And we are going to return that as the answer, which we can see mentioned over here. For this problem, also one more thing that I'm going to explain that is not shown in this problem, and that interviewer is going to focus on, is that currently in both the examples, all the values we are given, they are sorted based on the starting value. So the smallest starting value is located at the first in terms of the intervals, and all the other they are in like ascending order. So that is why we can clearly see in this case that okay, this is the overlap and we can resolve it quickly. But in the actual scenario, that is not a requirement. So it could be possible that the given inputs are not in sorted manner, and we will have to find some trick to solve this one. There is also one more thing with this problem, and that is that to find the optimal solution for this problem is easier than finding a non-optimal solution, and that is tricky. So in the end, I'm just going to show you like a very small non-optimal solution, but that you can use sometime in the future, or if you just mention it in your interview, it is going to amaze your interviewer. So first, let's see a quick example with the optimal solution. Okay, suppose this is the input we are given, and now we need to find all the merge intervals. Now if you see this input, it becomes really difficult to find like what are the intervals that are doing or that are overlapping with each other. So now what would happen is that, for say for example, we are this interval 1 to 9. If we want to identify that does there exist any other interval that overlaps with this interval, then we will have to go through every single value inside the given input and then make some changes. Same way for 2 to 5, again we will have to repeat the same process. So basically if we keep on doing this, this is going to lead us to solve this problem in big O of n square time, which is not what we want. We want a better solution, and the better solution can be achieved if we simply sort this given input. And how we are going to sort this given input? We are going to sort this based on the starting values. So the smaller starting value is going to be located at the first positions, and the larger starting values are going to be located at the last positions. And after sorting, things will become much more easy for us. So let me just quickly draw the sorted solution, and then we will see that what would be the trick to solve this problem. Okay, now we have our sorted input ready. Now things are going to be much more easier for us. Basically what we are going to do is we are going to create a new merge interval array, or inside the new merge interval array, first of all we are going to check that okay, this is the first position that we will have to add. Okay, so let's just add this first position 0 3 we already added. Okay, now for the second position there are two possibilities. First possibility is that either these two, they do overlap or they don't. Now in this case, how do we check that whether they overlap or not? We check it based on the starting and ending values of this existing variable or this existing interval, which is 0 and 3 in this case, and we check it with the starting value of this new interval. So because starting value of this new interval falls between the ending and starting values of this previous interval, we can define that there exists an overlap. Now if there exists an overlap, then there are two possibilities. We basically need to find the starting and ending values for each one of them. Starting value is going to be the lower value between both of the intervals. Ending value is going to be the higher value, and that is simple. That is all we need to do. And if we keep on repeating the same process with all the elements that are next to each other, eventually when we reach to the end, we would have find a new set of array that does not contain any overlapping intervals, because we would have merged every single one of them. And let me quickly show you how we are going to do it. So first we find, okay, 0 3 and 0 1, there is an overlap. Now because there is an overlap, we will have to choose what we need to add. We are going to pick the lower value between 0 and 0, lower value is 0. Higher value between 3 and 1, higher value is 3. So 0 3 is going to be the overlap. Now we are going to get rid of this first element, and now we are only going to focus on the second with the next element. So currently this value is 0 1, this value is 0 2. Again 0 falls between the values 0 and 1, so there is an overlap. We are going to see, okay, what is the smaller value? 0 is already present over here. What is the greater value? 1 2. But we do not care about 1 2. We will have to compare the greater value with this one, because this is the entry we already added. So now we are going to compare this 3 with this 0. In this case, because 3 is greater, again we are going to get rid of this one. We can also get rid of this one, and now we are at this position. Again we are comparing it with this one. So now, okay, 0 and 3 and value is 1. 1 is between 0 and 3, which means there is an overlap, and we are going to create a 0 to 9 over here. Now again we are going to get rid of this one. Now we are going to compare it with 2 to 5. Again 2 and 0 to 9, so 2 falls between, so there is an overlap. Definitely between 2 and 0, 0 is smaller, so we are going to keep 0 as it is. For this 5 and 9, 9 is greater, so we are going to keep 9 as it is, and we are going to get rid of this one. Now we are at this position. For this next position, the starting value is 10. 10 is greater than the ending value of this previous interval, which means there is no overlap. Because there is no overlap, we would be able to add this 10 and 11 as it is. Now after adding 10 and 11, now we are no longer going to compare with this 0 and 9, because we already found that 0 and 9 are located at the correct position due to the sorting property of original input that we have modified. So in this case, since this is 10 and 11, now we are going to compare 10 and 11 with 12 and 20. So again, 12 is greater than 11, so which means there is no overlap between these two, so we can add 12 and 20 over here. Awesome. Now after adding 12 and 20 over here, we see, okay, this value is 19. So 19 is less than this value 20, which means that there exists an overlap between these two values. Because there is an overlap, we will again have to repeat the same procedure. So the procedure we are going to repeat is between 12 and 19, we are going to pick the smaller value, which is 12. Awesome. between 20 and 20 we are going to pick the greater value, which is 20. Awesome. So in the answer we are simply going to have these three values that we are going to return. First interval is 0 to 9, where we merged bunch of different small intervals. Second one is 10 11 because it was not overlapping with anyone else, and the third one is 12 20 because there was an overlap between these two intervals. And this is the full solution of this problem. Now if we see the time complexity for this one, the time complexity is actually going to be big O of n log n, because n log n is needed to do this or to generate this sorted result, and then we can solve this problem in big O of n times. So it's going to be big O of n log n plus big O of n, but in general we can write it as big O of n log n. If we see space complexity, now this is debatable. You can argue with your interviewer that because we are creating a new array, we can consider space complexity to be big O of n, or if the answer by itself needs us to create a new array, then we can consider the space complexity to be big O of 1. So this is debatable. You can discuss with your interviewer what you want to do to solve this problem. Now let's just go. Now I have shown you the optimal solution. Now let me go back and show you the non-optimal suboptimal solution where we can solve this problem. Suppose we are given a set of interval that looks like this. Okay, so suppose this is the input we are given. Now I'm showing you suboptimal solution for your knowledge only. So what we can do is we can create a graph solution and we can find all the connected components, and then we would be able to solve this problem quite easily. What we are going to do is we are going to treat every single value as the node in a graph. And remember, graph is made out of two things, node and edges. So as a node, we already identified that these are all the tuples that are considered as node. What we are going to treat as the edge is the fact that if there exists a value, so say for example, this 1 to 5 is a node. Okay, so let me create a node over here. Now, if there exists a value where the starting value is between 1 to 5, then we would extend an edge from this node to that next node, which in this case this value is 4 to 7. So 4 to 7, the starting value is 4, and because starting value is 4, we can actually create an edge between these two, stating that these two are connected. And what we mean by connected is that there exists an overlap between these two values and we will have to resolve them. So this is first way. Second thing, again we are going to repeat the same thing. Okay, so let me just take down this value 6 to 10. Again we are going to create a node 6 to 10, and then we will try to find, okay, does there exist any value that starts between 6 to 10? Yes, the starting value of this value number 6 is actually between these values 4 to 7, so we will extend an edge between these two values as well. Now notice in this case there is no edge between this value 1 to 5 because this one is only limited to 1 to 5 values and the starting value of this one is 6, so hence there is no edge between these two. Again, if we take the next example 15 to 17, okay, 15 to 17 is the new node, and if we see 16 to 20, so the starting point of 16 is actually between 15 to 17, so again we can extend an edge over here, and for this new tuple we are also going to have a new connected component, and again there is no correlation between these two. Now all we need to do is that all the values that are connected with each other, we will have to resolve them and put them in one single merged block. So in this case what will happen between these two values is that from 1 to 5 and 4 to 7 we can clearly make a new node that is 1 to 7, because we are taking the smaller value of the starting point and the greater value of the ending points. Again, between this 1 to 7 and 6 to 10, what we can do is we again take the smaller and larger value, so the answer is going to be 1 to 10. So from these three connected components we can actually make a merged node that is 1 to 10, and from these two connected components we can make another merged node that is 15 to 20, and these two are what we need to return as the non-overlapping conditions. This is just for an example purposes. This is a suboptimal solution. Why this is a suboptimal solution? Because in order to generate this graph, it is going to take us big O of n square time, and that is why the time complexity is actually suboptimal compared to our optimal solution. Now let's move on towards the second example. In the second example, we are actually going to learn about that how can we insert an interval in any between any two intervals, and where we are going to do the reverse of what we already did. If we see some of the popular companies who have asked this question, there are companies like Google, Amazon, Facebook, Microsoft, LinkedIn, Apple, Bloomberg, ByteDance. So they have all asked this question, which means this is a popular question. And if we take a look at the problem statement, it states that basically we are given an array of non-overlapping intervals where we are given the definition that any single tuple inside the array defines the starting and ending point of the interval. We are also given a new interval and we are also given the starting and ending point of this new interval, and we simply need to insert this new interval in our existing set of intervals. We are also told that we need to make sure that there does not exist any overlapping intervals after we add this new interval. So if there is an overlap, we will have to simply resolve that. In this case, a good thing we are told is that all the original input intervals, they are already sorted in the ascending order based on their starting values. So this is a huge benefit for us. So first let's try to understand this with an example. In this case, we are given two intervals already. So first one, the value is 1 to 3. So let me, okay, 1 to 3, and second one is 6 to 9. So that is 6 to 9. If we see the new interval we are trying to add, that is 2 to 5. Okay. So 2 to 5, 2 will fall someplace over here and 5 will fall someplace over here. So 2 to 5 is the new interval we try to add. If we add this new interval, what is the answer is going to look like? Again, it's pretty simple. 1 to 5, this is going to be the first interval after we merge these two, and then 6 to 9, since we are not doing anything, we can simply keep it as it is. Solving this problem is actually quite simple. How we are going to do it is that if we simply just go iteratively, so say for an example, we are given an input that looks like this, where we are given, okay, this is the first interval, this is the second interval, and this is the third interval that we are given as the input. We can put any arbitrary values. Okay, it's 1 to 3, then 5 to 7, and then 9 to 11. This is okay so far. We are given a new interval, new block that we are trying to add. This new block is spanning between the values, let's say these values. So the value is 2 to 6. This is the new block we are trying to add. What we can do is, first we will see for the first block, we will see that whether this first interval starting and ending value, does they merge with, or does it overlap between the new interval we are trying to add. Since the starting value of this new interval falls between these two intervals, which means immediately we will have to run the overlap function. So if we run the overlap function over here, the answer we are going to get is, we will start, okay, so this is going to be the value number 1, and this is going to end at value number 6. And currently I'm just merging these two intervals, nothing more than that. So this is the after first iteration, and meanwhile we already have our existing values. So 5 to 7 is still present, so we will have 5 to 7, and also 9 to 11 is still present, so 9 11 is also present. Again, if we do repeat the same process, so between this interval, again we will do the overlap. After doing the overlap, basically we would end up with a new interval that looks like 1 to 7, and we can get rid of all the previous one, and this one is already 9 to 11, and since there are no overlap right now, we can return this as the answer after inserting the new interval that does not break any, or that does not create any overlap. But what would be the most optimal solution? Well, this solution works perfectly fine. If we see time complexity is actually going to be big O of n, which is pretty good. But the thing is, whenever, this is a golden rule I'm talking about, whenever you see any input where the given input array is actually sorted, if that is the case, if the given input array is sorted and you are able to solve this problem using big O of n time, then if you use the sorting property and if you use binary search, you would be able to solve this problem in big O of log n time. This is a great tool to remember because you are going to use it a lot of times in many different problems. So again, if we are going to use binary search in this problem to solve this problem in big O of log n time. Now in this case, because I'm using binary search, I'm not going to show you this small example because it has very limited test cases. Let me just draw a bigger case, and then we will try to see that how to best use the binary search in any given situation. So suppose this is the input we are given. Let me just mark some arbitrary values. Now the new block we are trying to add is that it is, say for an example, it is between these two values. So value is let's say 6 and 10. This is the new block we are trying to add. Now, since I already know that the starting value of this new block is already 6, do I need to go through every single one of the intervals to see where there could be a potential overlap? No. What I can do is, since I already know that all of these values are sorted and there is no overlap between any of the existing input results, simply using these values, I can try to find that, okay, what is the interval where there could be a potential conflict, and that I can pretty easily find over here. So simply I can see that where does 6 fit between all of these starting values, and immediately the answer is that 6 between the values 5 and 9. And now all I need to do is that for this interval 5 to 7, does 6 fit between them? So yeah, 6 fits rightly over here. So I can definitely know that I will have to do a merge operation over here. I know how to do the merge operation, the picking the smaller values between these two and picking the greater values between these two. After picking the smaller and greater values, we have already eliminated the starting position of this one. So we already took care of this part. But now we will have to take care of the ending part as well. Now for the ending part, again, what we need to do is we already know that all the values are stored in the ascending orders, which means we can say that which is the block after which definitely there cannot be any kind of overlaps. So we find that the first value that is greater than 10, and that is a start of an interval, that is 13. So we can clearly see that all of these values, they are never going to be a part of any overlap that would be caused by this interval, because the ending value is 10. So we will check one previous value. The previous value is currently 9 to 11. 10 falls right between them. Because 10 falls right between them, we are going to do a merge operation, and eventually we would create a new value that is between 5 to 11, and all of these values, so 1 2 3 and then all of these 13 to 15 and so on and so forth, they are all going to be as it is. Now notice that even though we had like 5 different intervals in the input, we only did 2 calculations because we used the binary search property of this original given input sorted array, and that is why things became much more easier for us. If we see time complexity now, the time complexity is actually going to be big O of log n, because this makes life much more easier to do the search operation. Okay, now let's just quickly go through this remove interval problem. This is a Leetcode 1272 number problem, and this is actually a Leetcode premium problem. So that is why I decided to solve this problem, because I know not many people can afford the Leetcode premium subscription, and since I already have it, I want to make the most use out of it. This is the Leetcode medium problem, and in this problem, basically, if you want, you can read this whole statement, but I'm just going to explain you that what it is asking us to solve. We are simply given an array of intervals that defines some intervals that we are already given, and these are already non-overlapping intervals. That is good in our favor. We are also given a new interval that we need to remove, which means if we remove this new interval, all the intervals that it overlaps, they needs to be removed from this original input list, and then we only need to return a new list of arrays or new array list that contains all the intervals that are not part of this to be removed part, and that is the answer we need to return. So let's just try to understand this with an example. Suppose again, just like this, we are given an interval that looks like this, and let's just give values 1 3 and then 5 7 and then 9 11. Okay, and then we are being asked to remove an interval that looks like this one. The value is 2 2, let's just say 6. Okay, this is what we need to remove, which means we can still keep this portion, but we cannot keep this portion. This we will have to get rid of, and even until this portion, everything needs to be getting rid of, but this portion we can still keep. So the answer in this case is going to be that first we will have an interval bit that is 1 to 2, then we won't have any interval until the value 6, but after the value 6 there exists an interval between values 6 and 7. So again, between 6 to 7 there is going to be a new interval, and then this 9 to 11 is going to left untouched because it was not part of this 6 to 11. So what the simplest solution we can do is, and in my opinion this should have been a Leetcode easy problem, not medium problem, but anyways, Leetcode has their own ways to decide. What we can simply do is, whenever we are given an input and we are also given the interval we are trying to remove, so if we just take a look at the same example again, basically what we can do is that simply we can check for every single interval that we iterate over to see whether it conflicts with this new interval that we are trying to get rid of. So in the first place, we check, okay, this value is 1, 2, 3. And the value that we are trying to get rid of starts at value number 3, which means that there exists an overlap between these two intervals. So because there exists an overlap, we will have to do something. And what we are going to do is, we are only going to pick the values between this 1 and 2. So between these two starting values, we are going to create a new interval and store it in our answer. So 1 to 2 is going to be the new interval. Then this part we don't care. Okay, now we are on the next interval. Again, for the next interval, we are going to check that does its ending value is greater than the ending value of the part we are trying to remove. If that is the case, which means there is a possibility that this interval will have some value that we can add in the answer. Suppose over here, if we had one more interval that looks like this, okay, I'm just giving you an example, then this interval has to be removed completely, because both of their starting and ending value falls between these two portions. So then we can't do anything in this case, which means that this interval is no use for us. So we will simply skip to the next one. But in this case, since this interval already has a value that is greater than the ending value of the part we are trying to get rid of, so then the value difference between the part we are trying to get rid of and the ending of this current variable, so that is 6 to 7, that would be stored in our answer. So 6 and 7 would be stored, and then all the other values, so in this case 9 and 11, will be left untouched, and we can add it to the answer. And this is the whole solution. Now if we see time complexity, in this case the time complexity is simply going to be big O of n, because we might have to iterate over every single value inside the given input. And in terms of space complexity, well, this is debatable. You can argue with your interviewer, since in this case we are explicitly told to create a new list and return that we are just simply creating a new array list, and then we are adding all the solutions to that. So in this case, we can mark the space complexity as constant. But if we are not being asked and still you are using a new array list, then it could be considered as big O of n. So you can discuss with your interviewer on how you want to treat the space complexity as. And this is the whole